Okay, let's start with the simplest example, which is a linear equation. Usually when you're learning something new, you want to understand what each of the words mean. We've already seen what equation means. The term linear means one of two things. It means that the variables have at max an exponent of 1. So things like x, y, or just numbers. And secondly, when plotted on a graph, it is going to look like a straight line. Now that's something I want you to keep in mind. Whenever you are working with a linear equation, you want to think of it as a straight line. How that's going to help is when you look at certain properties of the linear equation, it would make sense when you picture them as straight lines. For example, y equals 2x plus 1. We saw last week how to construct a table and plot a graph of this function. Let's say I take the test points 0, negative zero point 0.5, and 1 for x, and I get a straight line as expected. Now this graph has certain interesting properties. For example, where does it cross the x-axis? Where does it cross the y-axis? What's the slope? Now that's all you can ask when you are working with one line. Now what about if you're working with two lines? So I'm interested to know what happens if I have two straight lines. Now here's a concept check. You can pause the video at this point and try and figure out how many different ways you can draw two straight lines, like all possible ways. Now hopefully you will discover that there are actually infinite many ways of doing it. For example, it could be any one of these pictures or a bunch of them. But again, now try and ask yourself if there are some cases here that are actually similar, and if there is some sort of classification that can be done. Now, if you look at the pictures that you've drawn, you will notice that one of three things can happen. The lines can intersect, meaning that they cross, or that they share one point. The lines never meet. These are also called parallel lines, which means they share no common point. And the lines coincide, which means they share all the points or infinitely many points. This symbol here, like a ribbon, is a symbol for infinity because it represents a loop. Um, so that's why that symbol is chosen for infinity. Let's focus on the first case, which is the intersecting case. Now, consider this green line and the purple line and this black point where the lines meet. This point is called the intersection point. Now, in general usage, we use intersection where as a point where two roads meet. So it makes sense to call this an intersection point. Certain observations about this black point is that it lies on the green line and it lies on the purple line. Now, is there any other point which has the same properties? No. When two lines intersect, they have a unique point of intersection, and this point lies on both the lines. That's all nice and good graphically. What does it mean algebraically? Now recall, when you think of a straight line in geometry, in algebra, it's a linear equation. So let's say I have two linear equations, 2x minus y equals 3 and x plus y equals 4. This is just an example. It's not a representation of the picture drawn here. Okay. A small concept check here. Can you rewrite these linear equations as y equals f of x and verify that they are linear? Now, let's pick an ordered pair like 2 comma 1. What happens is that I notice that it satisfies the first equation, and I can check that by plugging it in. 2 times 2 minus 1 equals 3. Algebraically, it means that when you plug in x equals 2 and y equals 1, the equation is true because 3 equals 3. And graphically, it means that the point 2 comma 1 is on the graph of this function, which is a straight line here. But the point 2 comma 1 does not satisfy the second equation because 2 plus 1 equals 3 is not equal to 4. Similarly, 2 comma 2 satisfies the second equation but not the first. Pause the video here and verify that for yourself. Now what we are interested in is in finding some point x comma y that satisfies both the equations at the same time. Recall that graphically it means that I'm trying to find a point x comma y that lies on both the graph. What is this point called? Intersection point. That's what we just learned previously. So let's find the intersection point. Here's the process. I make an observation that if I add these equations, I can get rid of the y term. So I add these equations. I end up with 3x equals 7. To solve for x, I divide by 3 to get x equals 7 thirds. Now I can plug this into any one of the two equations. Let's say I plug it into the second one. 7 thirds plus y equals 4. Y is 4 minus 7 thirds. I rewrite 4 as 12 over 3 to have a common denominator, and I get 5 thirds. This means that the intersection point can be written as x comma y equals 7 thirds comma 5 thirds. Now, you can also plug the 7 thirds into the first equation to get 2 times 7 thirds minus y equals 3. Now, you can go ahead and complete this, and you should get the same answer because no matter which way you solve, the intersection point has to be the same. Okay. In the next video, we will be looking at some more examples. That's it for this.